So we love to solve, so I don't know about you, but I've come back with another question here saying start the diagram below, take pi to be 22 over 7, and this is a sector. In fact, there are two sectors inside, right? So we have the sector O A, let me say A or D, so it's one sector, and another sector is B or C. So there are two sectors. So in short, we can say we got OAD and OBC, those two sectors. So the angle is common, but we've got OD, which is 7 centimeters, and DC, which is 2 centimeters. That means even OA is 7 and the AB is what? 2 centimeters, because we know the properties of a sector. Now, how do we find the shaded area? We need to find the area of this shaded region. Now, what we need to do is we are going to use this method. If we know the area of a smaller sector, then we know the area of the bigger sector, then we can subtract them. Then what remains is the area of the shaded region. Let's do that. So part A, so the shaded area is just equal to area of, all right, sector OBC, which is the bigger one, minus area of sector OAD. This is a formula which we are going to apply. So let us first find the area of sector OBC. So area of OBC, it is a sector, the bigger one. Let's do that step by step. So OBC, how do we find the area of a sector? So area of a sector is given by what? Theta over 360 degrees multiplied by pi r/t squared. So the area, the angle is 120, so we're going to put 120 here, degrees over 360. Pi is 22 over 7. The radius, now for OBC, the radius is this one plus that one, because we're looking at the radius of the bigger one is the addition, is the summation of OD and DC. So we're going to get 9, not 2, not 7, but the total 9, because you're talking about that length. So we're going to put 9 times what? 9, because we are squaring it. All right. It's making sense, isn't it, ladies and gentlemen? I hope so. Well, so let us punch this on the calculator. 120 over 360, we get that one. Then let's multiply that by 22. Okay, we can start with this. 9 squared is 81, right? Good. We multiply by 22, then we multiply by 120, then we divide by 7, then divide by 360. Well, I'm getting 84 point, I'll round it off to one decimal place, so I'll say 0.9. This is the area, and are those centimeters? Yes, all right, so they're centimeters, so centimeter, square centimeters. So this is the first area. Let's call it area 1 for the OBC. Now, step 2, let us also find the area of sector OAD. Let's find the area of sector OAD. So area, same formula. The formula is here, so I'm not going to copy it again. I'll just plug in. The angle is the same, but the OAD is a smaller sector, so the radius is 7. So we are saying it's 120 degrees over 360 degrees multiplied by pi is still the same, and the radius is 7 now times what? 7, because we are squaring in time. All right, so area is therefore equal to 7 squared, you know that is just 49, and 49 times 22 times 120, we divide by 7, again we divide by what? 360. I'm getting 51.3 square centimeters. Let's call this one area 2. So this is the area of the smaller one, and this is the area for the bigger one. Now the area of the shaded region, remember what we said, is the area of a sector OAB minus the area of a sector OAD. So therefore the area of a shaded, that's a shaded area, is therefore equal to A1 minus A2. Don't rush. Show them that you know what you are doing. Eh? So 84 minus 51.3. So I have 84.9 minus 51.3. Where I'm getting 33.6 square watt centimeters. And you are done. Let's go to B. It says the perimeter of this area. Now, the perimeter is the distance around the circle. So you add everything. We are going to sum up everything. So we are going to sum, so for this, now let me just, so the shaded region is there. So we are going to sum, we are going to find that distance. We add with this distance. We add with this distance. Then we also add with that distance. But we know that this is 2 centimeters, so even there is 2 centimeters. So the only thing that we need to do is to find the length, this one, and that length there. Alright, so let us find the length of BC and the length of AD, then we add the kurika 2 and 2, then we would have found the what? The perimeter. Alright, so let us find length AD. So let's go length AD, let's find it. Is theta over 360 multiplied by what? 2 pi r, which will give us the theta is 120 degrees over 360 degrees multiplied by 2 pi is still the same, 22 over 7 multiplied by the radius for the smaller one, remember it's 8d, the radius for the smaller one is what? 7, so we are going to put 7 there, such that this and this one they cancel, so whatever that remains will be our length, 120 over 360, then we multiply by what? 44, because 2 times 22 is actually 44. So the length is 14. The length is what? 14.7. I'll round it off to 1 decimal place. Then now let's go and find length BC. Length BC is still theta over 360 degrees multiplied by 2 pi r. The angle is still the same, over 360 is still 2. The pi is still 22 over 7. Now the radius now is no longer 7, but remember we're talking about BC, so it will be OC, which is 9. So we put 9 here. Then we punch on the calculator. So we have 120, we multiply by 44, we multiply by 9. Then we divide by 7, we divide by 360. It's giving me 18. Let me set to 1 decimal place, 18.9 centimeters. Now, therefore the circumference is equal to, we are going to add the AB. We are going to add the AB plus AD plus BC plus this one here, DC. Then we are done. So what is AB? AB and DC, they are same, they are 2. So just put 2 here. Therefore here we put that one, 14.7. BC is 18.9. DC is 2. Then we add them. That's all. So 2 plus 2 is 4. And plus 14.7 plus 18.9. Yeah. The circumference is giving me to be 37.6 centimeters. That's the circumference. Wow. Beautiful, huh? That's how we do it. So I hope you enjoyed the video. Cheers.